By turning the crank, two rollers smash the plate together and pull it forward. Watch closely. In this video, we're going to study how this mechanism works. This video belongs to a playlist called the Mental Mechanism Library, in which we're going to study products all around us, figure out how they work internally, and save their mechanisms in our Mental Mechanism Library. This is going to make you a better mechanical design engineer. One feature I like about this product is the Murcielago doors, kind of like the car. Unfortunately, we can't tear apart the whole product because behind the logo that goes here, behind this oval shape, this is an insert, there's a screw behind it. And in order to disassemble the product, we will have to break it because we can't get this oval out. Thankfully, this is a product that was designed here in-house at teampipeline.us, so I do have access to the full CAD model, and I'm going to show you how the mechanism works internally. Prior to explaining the mechanism, let's take a look around the CAD model so we can gain an appreciation for the mechanical design that was involved in this. As you can see, all the little fasteners, everything is here. It's all designed for manufacturing. These are plastic injection molded parts. Let's look at it, take a look at it from the bottom. And where things get really interesting is when we start making the exterior housing transparent. So let's do that next. Transparency. Now we can see the gears that are happening inside. And in fact, let's make the doors also transparent. So let's focus on these two rollers. This is the mechanism that we're interested in. And how does this all happen? So your hand is placed on the crank, and as you turn the crank, we'll see the shaft that's connected to the crank will rotate, and the shaft is connected to a gear. Now this gear will change. Let's call this gear 1, the small gear. Gear 1 engages with gear 2, the teeth right here, and I'm going to show you in motion. Gear 2 is connected to the roller, which, as you can see, as gear 2 turns, the roller is going to turn. And gear 2 is connected to gear 3, and gear 3 is connected to the roller. So that is the simple mechanism. One of my goals with the Mental Mechanism Library videos is to equip you with not only mechanisms, but knowledge on how to utilize SOLIDWORKS so you can become a valuable contributor to an engineering team. One thing that I want to show you is something that I haven't learned in any SOLIDWORKS class that I've taken. So any SOLIDWORKS class, to my knowledge, doesn't teach what I'm about to teach you. If I'm incorrect, please leave a comment below. But what I'm going to teach you is the skill of when somebody else designs a top-level assembly, which is the top-level file which contains all the sub-assemblies. How do you go about examining the top-level assembly? We're going to call that TLA, so that whenever you want to cause a motion, you can in fact make it happen. So right now we want to turn the crank, but we can't. I'm holding down my left click and I'm trying to rotate the crank and I can't. And I want to know why, which mate is restricting this motion. Now I have a simple six-step process. Step 1, step 2, step 3, all the way to step 6, in which I'm going to show you how to basically decipher what is the mate that's restricting this motion, how to access it, suppress it, and then have the motion that you desire. Step 1. Logically, you want to start at the TLA level, top level assembly, and verify if any mates in the top level assembly are preventing the motion. Let me provide some context. So when you're in the top level assembly, you have mates that are in the assembly itself down here, and then you got mates inside the subassembly. So this is a subassembly, and there are mates inside the subassembly. So it's important to make that distinction. And nobody ever taught me to read a feature tree in a class, so I'm going to take the time to walk you through that. And it's all about reading it from left to right, and almost like there are folders that are under another folder. So this subassembly contains all these parts that I'm highlighting in blue. And you know that because it's slightly off to the right, and that's how you read a feature tree. So going back to step 1, we want to verify if there's a mate in the top level assembly that's restricting the motion of us moving the crank. So this is how you inspect the top level assembly. First, you click on the item and the component that you want to move around. And you want to see on the left side here on the feature tree, where may it belong in? Well, it's the sleeve, but I want to see what subassembly. You see a little blue icon, does it belong in? So I click on the subassembly and everything turns blue. In fact, yes, this is what I was interested in. So then I'm going to read the mates that are in the top level assembly. So be very careful what folder you look under, because these would be the mates that are inside the subassembly. I want to look at the mates that are at the top level assembly. Okay, so we look right here, important to understand that distinction, and we hover our mouse going down and we start looking at the different mates. As we're hovering the mouse, my eyes are on the right side of the screen. I wish somebody would have taught me this. So my eyes are on the right side of the screen and I'm hovering my mouse down. And in fact, I must say that my colleagues here at Pipeline have taught me a lot of these skills. When I say I wish somebody would have taught me this, I mean like in a class. No one taught me this in an official SOLIDWORKS class. So my goal is to provide you industry skills by watching these videos. So I'm scrolling down and I see nothing that could constrain the rotational motion, because this comes with experience, but concentric, that's not going to constrain rotational motion unless it's you have the little check mark that's constraining the motion, and something should be noted here. I forgot the exact terminology. So none of these mates are preventing the rotation essentially. So step 1, clear. Let's move on to step 2. Identify the subassembly that could have the motion but isn't moving in the TLA, and open it to see if the subassembly does in fact have motion. So we identified that the subassembly here of the crank handle is not restricting any motion. So let's move up the feature tree, and I'm going to walk you through. You move up, 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 you come across the next subassembly. Let's click on that and it all turns blue. So we know that this crank must be mated to this subassembly. So let's go ahead and open it. We open the subassembly. Now we want to test to see if this can rotate, and it can't. Right now I'm holding down my left mouse and I'm trying to make it rotate and it can't. So the next step is, okay, identify movement delay, open to see if some motion. Okay, figure out which mate is constraining the gear and limiting its motion. And you want to start at the input. So let's go ahead and click on this part, as step 4 indicates. And pardon me if I'm going too slow. It's just I wish the right way to teach SOLIDWORKS a lot of times is with a mentor, and people actually take their time, like I'm taking my time right now, and gladly I'm doing this to show you how to work SOLIDWORKS. So I'm clicking here, okay, spur pinion, it's not moving, and I am curious now, a little hack here, you can click in the property manager and it's going to show you all the mates relevant to this part. Now all the grayed out ones mean that they're suppressed, they're not active right now. So let's scroll, the same tactic that I showed you before. Let's look through here. We know the concentric are not going to limit the rotation. Coincident, not going to limit the rotation. Not going to limit the rotation. Parallel. We found our suspect, because if this face is parallel to this plane in purple, parallel is constrained. It will not allow it to rotate. So we found our suspect. Now we're going to suppress it, which should allow for rotate. Yes, we're making progress. Okay, I'm getting happy here, and I'm gonna rebuild, save, and now what would the next step be? Step 4, step 5. Found the mate that's restricting the motion. That's what we just did. Step 6. Okay, we're gonna give the subassembly flexibility. So now we're gonna migrate over to the top level assembly. We saved it, we suppressed it. Now we migrate over. This is a good sign. We want to update because some things have changed. Let's see if we can move the crank. We still can't. And you ask yourself why? Well, you need to make your subassembly flexible. So we go here, not the crank, but rather this one. So right now it's stiff. It needs to do yoga. It needs to have some flexibility. We look around. There's a little icon, make subassembly flexible. Moment of truth, ladies and gentlemen. And there we have it. So, if you appreciated this tip, if you learned something new today, and you like the mechanism videos, please leave a comment below. like and share. It means the world to me. My name is Rafael Testai. See you soon.